Hey, I thought I would give you a little peek at I think is important transition in student learning, or very important transition in student learning, and that's going from the just the code-centric, getting some output on the screen mode to one where you're interfacing with a physical device, some type of IoT device, some type of maybe standalone robot or what have you. So I thought I would share this with you to kind of illustrate what I think is a quick first step in that kind of regard. So I have my camera here focused on this site, makecode.microbit.org, and then I logged in and I created a very little project. Matter of fact, you can see it's literally, if we look at that right there, it's literally this tiny little bit of Python code that's causing this note, this very low frequency C note to be ringing out forever. There is this nice visual and accompanying simulation where you can play that on the computer and it will generate a tone. And then I find the really powerful part, and this is what I've been really trying to get to here, is getting the students to realize that there's so much in the world that hinges upon little microcontrollers like this controlling processes of maybe much bigger systems. Could be a factory system, could be a home, entertainment system. It could be a part of a system that's running a car. It could be so many things. Could be part of an appliance that's used in the home. If we look over here, what I've done is I've uploaded, and this is just basically where I've connected the Microbit to my adapter to the laptop. But I've basically, and here's the Microbit itself, and I've taken the cues exactly from the emulator right here, and I've taken the cues where you can see that there's a ground and there is a signal connection, and they're connected to the end of the, if you look at that, the end of that plug, that cord, the end of the plug on the cord is connected to the signal, and then the base of the plug on the cord is connected to ground, and that's exactly what is done over here. Over here we got the end of the plug connected to the signal, and that's what I have in red. And we have the ground of the plug, and here I have it in yellow, and it's connected to the base of this plug. So again, the head of the plug right there is connected to the signal, which is basically an amplitude modulated voltage, and it's a very low voltage, right? We're not talking, these devices, very low voltage. Pretty much all the microcontrollers you're going to be dealing with are going to be either like 3.3 or 5 volts. So if we're talking like just over 3 volts, that's not a really big difference, going up and down in amplitude, but nonetheless, that's how it's changing that signal over time. And then that signal is getting driven into this plug, which is going over here to this nice little, just a little test speaker that I have. And then that signal is going into the voice coil of that little speaker, and the voice coil is getting an induced magnetic field that's interacting with the permanent magnet there, that's causing the dynamics of the speaker cone to be moving back and forth and generating that sound that hopefully you can hear. Hopefully it's not too annoying. But that's what we get right there, as I believe a very minimal kind of step from just doing code and doing maybe a little visual, which I love, which I think is the most important way to start with something visual like CMUC's Academy does, or perhaps do something to augment it with something that's more auditory. Now you can make sound on CMUC's Academy as well, but you can also make sound really nicely on Georgia Tech's site. I don't know if I should include that right here, but Georgia Tech has a site called EarSketch, and the EarSketch application and curriculum is very wonderful. I still lean towards CMUC's Academy for sure for the general entry point, but some people will get a lot out of that EarSketch application. But there we have it, about the simplest thing you can think of right there, just like a couple lines of Python code, but we have this connection. It's like, hey, we just programmed this little microcontroller, but that microcontroller, even by virtue of its name, you think it's controlling something. That it can be controlling these things that are connected out to it. And this is something that's also being controlled at that line level voltage. But it doesn't have to be something controlled at that direct line level voltage. Obviously, we can have another circuit that interfaces with this via, let's say, a relay. And the second circuit can be a very high power circuit. Typically don't have students starting off with relays and high power stuff, but I think you can do a demo for the students at a certain point to say, hey, yeah, we got different types of circuits, some that run at a very low voltage, low power, line level, if you will, and other ones that are kind of running at a higher power. And maybe that's a good way to get into some serious electronics and circuits and physics and so forth. But yeah, that's what I have to share, and I wish you the best. Go ahead and reach out if you're interested in talking about this stuff and making good units, making people, you know, see the connection to these kind of controller devices that are all around us. Peace.